The hero of this story is a master of disguise. To some people, he's appeared as a wedge shape. To others, as a cone. But no matter what shape he may have taken on, he's always been number one. His story is our story. It's a story of struggle, of knowledge, of where numbers come from. We'll see how one helped create the first cities, how he helped build empires, how he inspired some of the greatest minds in history, and we'll also find out his part in making money work as it does. Oh, thanks. And finally, we'll see how one teamed up with Zero to dominate the world we live in today, the digital world, a world that runs on ones and zeros. These words that I'm now speaking were first written down on my computer using a code of ones and zeros. Even my image coming into this digital TV has been sent through the ether as a series of ones and zeros. So how did these two digits come to dominate our world? They didn't always. In fact, for most of human history, zero simply didn't exist. It's one that really counts. So where did one come from? Well, his story begins at the dawn of time. 3,042,659 years ago to the day, the first primitive one crawled out of the primordial soup onto dry land. Nah, not really. Just joking. In fact, the origins of one are shrouded in mystery. It's a mystery that only our earliest ancestors can answer. At some point, one of them must have been the first human being to use one to actually count with. But when? Ever since man could make marks on bones, he's been, well, making marks on bones. But what about the fellow who scratched marks like this 150,000 years ago? Is it possible that he could have been counting? Could these scratches represent a series of ones? Well, the experts tell us that, giving due weight to the scientific and archaeological evidence, they haven't a clue. What they're now pretty sure about is that one is a lot younger than us. It's not until quite recently, a mere 20,000 years ago, that we get the first really solid evidence that one existed and that someone was using it for counting. Of course, he didn't look like this when he was born. Back then, one was just a scratch on a bone. This bone. It's known as the Ishango bone. It was found quite recently in the Congo. And look, you can see these scratches. We know that each represents a one. How can we be so certain? Well, someone must have been counting, because there are 60 scratches along this edge of the bone and another 60 along this edge. And on the back, they're in equally numbered groups. And you can't do that without counting. The Ishango bone may mark a defining moment for mankind. Zoologists tell us that other mammals are able to count up to 3 or even 4, but not beyond. By turning one into a scratch, our early ancestors could count to 4, 5, 6 if they were real clever clogs. In fact, they could count any number of wands they wanted. And that is what gave us the edge over the lions and the tigers. From now on, counting knew no limits, and one was growing up into a big boy. In the meantime, human beings were moving up the property ladder. And that would change one's story forever. They stopped living in caves and started to build their own caves. Houses. The next great event in one's life was to happen in the ancient civilization of Sumer. Here in the Middle East in about 4th... there you are. Around this time, the people of Sumer decided to give one his independence. They stopped scratching on a bone and set him free by representing him as a token. This transformation changed not only one's life, but the course of history. The invention of tokens allowed the Sumerians to do something that nobody had done before. If you add notches to a stick or a bone, you can do just that, add. But with tokens, you can take away. So, say you've got 6 chickens and you eat 5 of them. Oh, look what you've got. Indigestion. No. You've invented arithmetic. It was the biggest breakthrough in one's life so far. But why did it happen here? To find out, we have to go somewhere where it didn't. Meet the Warlpiri of Central Australia. They're people who've been minding their own business here for 30,000 years or so, until some anthropologists came along and noticed that they didn't use numbers.
People get very interested in Warlpiri because in our language we don't use numbers. We have a word for 1, but that's about it.
Until recently, the Warlpiri have got by without using numbers. How on earth have they been able to manage?
The things that you do in your world are done differently here. Take Jabulari here. He never grew up with any numbers at all. Never Jabulari. I'm not Martada. Kendra. Kalaminidam Kudo. Pun. Bijan.
Jabulari names his grandchildren. What he doesn't say is 4. It's just not in his vocab.
Pun.
Older generation Warlpiri don't talk in terms of exact times of day, just the position of the sun. They don't even deal in distances because their land is mapped out not with numbers but with songs, which contain all the information they need. These timeless songs, deeply rooted in their culture, are a source of huge national pride.
I should be so lucky, lucky. I should be so lucky in love. Oh yeah, I should be so lucky, lucky.
The fact is, in traditional Warlpiri life, they didn't really need a number system, let alone arithmetic. So why, on the other side of the world, 6,000 years ago, did the people of Sumer feel the need to turn 1 into a token and invent maths? What was so different about life in the Middle East? I mean, why were people here so keen to get into maths, of all things? Maybe it was because there were so many people living in the same place. unlike the Walpuri, the Sumerians lived in cities. And cities need organising. Grain had to be stored and distributed, and working out how much each person should get required arithmetic. That's why the Sumerians turned one into cone-shaped tokens. Tokens made possible the arithmetic required to assess wealth, calculate profits and loss, and, more important perhaps, collect taxes. Yes, you can blame the invention of maths on city life. The ability to do arithmetic wasn't the only thing the Sumerians needed for their civic programs. They also needed to be able to keep a permanent record of their calculations. But hold on, the written word hasn't been invented yet. Numbers, it seems, were the world's first writing. It happened like this. Specific numbers of cones would be put into clay envelopes for safekeeping and then sealed up. But once you'd sealed the envelope, how could you remember how many cones it contained? Bit of a problem, that. But wait a minute. They took another cone and made the same number of impressions on the outside of the envelope as there were cones inside. Then some bright spark realised you didn't need the envelopes in the first place. In fact, you didn't even need the cones. You could just make the marks straight onto a clay tablet, and hey presto, you had a record of the number. The notion of writing had been born. Sumerian mathematicians were now able to keep permanent records of their calculations, and these could become more complex than ever before. Only a select few were initiated into the mysteries of numbers, and they were trained from childhood. They became a powerful and highly paid elite that we still pay homage to today. That's right, the Sumerians' great gift to the world, the Chartered Accountant. One was now disciplined and organised as never before. He became a powerful tool, one that could be used to build empires, which is precisely what happened to one in his next incarnation. In the hands of the Sumerians, one had become part of a complex counting system. The Egyptians were going to stretch his talents even further. As well as walking very slowly, not smiling and standing in formation, Egyptians loved big things, big buildings, big statues, big armies. They also came up with some really big numbers. And the way they wrote them down provides a fascinating reflection of the hierarchy of Egyptian society. First come the numbers of drudgery and everyday toil. One was a plain, unadorned line. 10 was a rope. 100, a coil of rope. All humble workaday numbers. But then come the numbers for aristocrats, numbers to impress. 1,000 is a lotus, symbol of pleasure. 10,000, a commanding finger. And then the number for pharaohs, a number the Sumerians never even dreamt of. 1,000,000. The sort of number only a pharaoh would need to count his prisoners. It was the first ever million, and the symbol they used was a prisoner begging for forgiveness. Or was it the accountant begging to be let off counting any more prisoners? In any case, one had never been busier. But one had another job the Egyptians wanted it to do, perhaps the most important job of all. they needed him to help out on the building site. The ancient Egyptians were enthusiastic builders with a keen eye for beauty. But you can't create beautiful buildings without measuring things accurately. And you can't measure accurately unless you know what your unit is. That is, what you mean by one. In solving this problem, the Egyptians would do something nobody had done before. They defined their own version of one. They based it on the length of a man's arm from elbow to fingertips, plus the width of his palm. One was now known as the cubit, the measure of everything. The undisputed ruler. These official wands, the master cubit sticks, were so important they were jealously guarded in the temples. From them, copies were made and given out. So right across the empire, whatever the building project, everyone knew what they meant by one. And with this simple measuring stick, the Egyptians were able to complete their vast construction projects with astonishing accuracy. If one hadn't become the cubit, some of the wonders of the world might have been, well, a little less wondrous. By transforming one from counting things to measuring things, the ancient Egyptians hadn't just opened up a whole new world of bespoke tailoring and fitted carpets. They had made one the measure of all things. One had become the ruler. But its destiny was even more special. One was about to become the essence of the universe. It all began about 2,500 years ago in ancient Greece, or modern Greece as it then was, because of a chap by the name of Pythagoras. Pythagoras. Did he have a theory or something?
The square of the hypotenuse in a right-angled triangle is equal to the sum of the...
That's right, Pythagoras' theorem. Bit of a bore, I never quite understood it.
Well, actually, I think that Pythagoras was a pretty interesting bloke.
Oh, yeah?
He had a school in which all his pupils had to give up their worldly possessions, eat only vegetables, and swear never to touch beans.
Why on earth not?
Pythagoras believed that when you fart, a bit of your soul escapes.
Amazing what you learn in schools nowadays, isn't it? It's true that Pythagoras was a little, well, weird's about the only word for it. He studied in Egypt and the Middle East, and on his return home set up his vegetarian school of maths. Here he devoted himself to exploring the wonders and mysteries contained in numbers. Pythagoras was the first man to come up with the idea of odd and even numbers, and he gave them sexes. One was male, two was female, and so on. He also had a thing about whole numbers, collections of ones. He realized that certain whole numbers make pleasing shapes. 3 makes a triangle, 4 a square. 1 plus 2 plus 3 plus 4 makes 10, which forms a magic triangle. Pythagoras was also convinced that 1 would eventually help explain one of the fundamental philosophical questions of the day. The Greek philosophers were forever trying to find out the one thing that everything is made of. One philosopher said everything's made of fire, another air, another water. Pythagoras said that everything was made of numbers, including music. To find out what Pythagoras meant, I've come to the Waterbury Garden Centre in Oxfordshire. Oh, thank you very much. All I need now is a mathematician.
Oh, I'm a mathematician.
Oh, what a bit of luck.
But if you want to find out about Pythagoras' music and maths, we're going to need some pots of rather different sizes.
Good Lord.
Perfect. Pythagoras wanted to understand why certain combinations of notes sounded so beautiful and harmonious. So if we play a pot, we get a note, la. But if I combine it with the note of this pot, la, it's rather a bad combination. Let's listen to them together.
Oh, yes, that doesn't work at all, does it?
But if I play this pot here, la, la, that's a beautiful combination. Let's hear them together. But why is it such a beautiful combination? And the answer is mathematics. The relationship between the weights of these pots is in a perfect 1-to-2 relationship. And it's that combination of whole numbers which makes this such a nice sound. As opposed to the first pot, this is sort of a 1 to 1.264, not a nice whole number relationship, which is causing the bad sound.
So Pythagoras is saying that the harmonies are combinations of whole numbers.
That's right.
Numbers that are collections of ones.
Pythagoras realised that these whole numbers are really why things sound so beautiful, and it excited him so much he realised that really mathematics was the base of everything, that it would explain musical harmony and the cosmos, and this is why he coined the phrase the music of the spheres. So, shall we?
Oh, I don't see why not, yes. If the beauty of music relied on whole numbers, Pythagoras reckoned, so too must everything. And since whole numbers are collections of ones, one must be the essential material out of which the universe is constructed. One had never been so admired. But ultimately, Pythagoras' whole belief system was doomed. And ironically, it was the triangle that made him famous, which was to prove his undoing. If one was at the heart of everything, it should also be at the heart of every triangle, even the right-angled triangle with two equal sides. The problem is, it's not. Pythagoras kept trying to make all three sides an exact number of units, but it just couldn't be done. When one of his disciples tried to point this out, the others drowned him. Pythagoras' whole belief system that the world was made up of units was a lie. Poor old Pythagoras, brought down by his own favourite geometrical shape. One, however, was about to embark upon a new career. Only first, he would have to become a little less real. Like everyone else before him, Pythagoras couldn't conceive of numbers unless they represented actual things. One was not a one unless it stood for one chair, or one step, or one television presenter. But the mathematicians who followed Pythagoras broke free of these constraints. Yep, Archimedes, famous today as the world's first streaker, but in fact the greatest mathematician of ancient times.
Eureka! Eureka!
Archimedes just loved playing games with numbers, and he took mathematics into the realm of the unimaginable, because in these games he allowed numbers to do impossible things, like working out how many grains of sand you'd need to fill the universe. And yet, daft as some of these mathematical games may seem, they sometimes came up with practical results that we benefit from to this day. For example, he was obsessed with what would happen if you took a sphere and turned it into a cylinder. What would be the difference in area covered? Well, personally, I don't give a fig. But for Archimedes, it was the proudest moment of his life when he finally succeeded in working out the formula. And although it was a piece of pure mathematical bravado, it did actually prove to be amazingly useful in the end. Because thanks to Archimedes, later mapmakers could take the globe and turn it into a flat map. One was no longer the essence of the universe, but he was helping to create a golden age of theoretical mathematics. But a new force was at large in the world, and one was about to be dominated by a people who had rather different obsessions. Archimedes lived in Syracuse, and when the Romans invaded in 212 BC, he was in the middle of a particularly gripping piece of calculation. In fact, he was so wrapped up in his work that all he could say was, "I beg you, do not disturb this." Perhaps not a wise move. It was the end of theoretical mathematics in the classical world. The Romans weren't interested in airy-fairy abstractions like how to calculate the weight of all the goats who ever lived. They were interested in power. Whether he liked it or not, one was now a servant of Rome. He had to leave the dizzy world of abstract mathematics behind him and get on with more practical concerns. He became the backbone of the Roman world, as the Romans used him to impose a rigid numerical grid on their army. There were 10 men in a section, and 10 sections, 100 men, were called a century. 2 centuries were called a manipulus, which means literally a handful, which I imagine 200 Roman soldiers probably were. Even punishments were dealt out on numerical principles. If a legion suffered a humiliating defeat, the entire legion was decimated, from the Latin word for 10, decem. Regardless of individual guilt, one soldier in 10 was killed. The great aim of the Roman world was to keep things ticking over. Theoretical mathematics just wasn't them. Mark you, I'm not surprised. I mean, the Roman numerals don't exactly make it easy, do they? I mean, look at them. They're just an elaboration of the old notches on a bone. The only sophistication being new symbols as the numbers get more unwieldy. V for 5, X for 10, C for 100, up to their symbol for 1,000,000. But it's still just a simple counting system. Fine for writing inscriptions on tombs, but not much cop for the complications of theoretical maths. Well, you try writing 1 billion like that. In modern numerals, it takes me about 8 seconds. I tried it. In Roman numerals, it would take something like 16 minutes. It's no surprise, then, that Roman numerals weren't even used for calculating. The actual calculating had to be done on a counting board, an early version of an abacus. The numerals themselves were just used for recording the results. Maybe it's no coincidence that, unlike the Greeks, not a single Roman mathematician is celebrated today. As Roman power spread, so too did its numeral system. Over the next 500 years, all of Europe, from Spain to Turkey, came under Roman control. And even when their empire eventually crumbled, their numerals were left standing. But though the Roman system might have seemed indestructible, it wasn't. Its nemesis came from the east, to be precise, from India, in 500 AD, or thereabouts. One had an Indian cousin who for some time had been living in a more rarefied atmosphere. The Indians seem to have been less concerned about military organization than about renouncing the world and finding enlightenment. But Nirvana isn't just down the road. To reach it is a very, very long journey, which takes a very, very long time. And to convey that fact, the Indians came up with some stupendously big numbers. Take a raju, for example. A raju is the distance covered by God in 6 months. If he travels 1,000,000 kilometers in every blink of his eyelid. Or how about a palya? A palya is the length of time it would take me to build a cube of lamb's wool 10 kilometers high, if I were to lay one strand every century. Here's one I made earlier. Well, these were the sort of numbers that could have made one feel, well, small, if he hadn't had a little help from his friends. Unlike the Romans, the Indians devised a system that could cope with vast numbers. They developed a different symbol for every number from 1 to 9. 1, 2, 3. Or if you do them quickly, you get Arabic numerals.
नहीं है, अरबी नहीं है, ये हमारा हिंदुस्तानियों का बनाया हुआ है. हम लोग हिंदुस्तानी इसे 2000 वर्ष पहले से प्रयोग कर रहे हैं.
He's right, you know. The numbers we use today are called Arabic, but in fact they began life here in India as early as 500 BC. But then, around 1500 years ago, or a little longer if you're watching a repeat of this program, someone came up with a stupendous, incredible, extraordinary idea. The biggest revolution in numbers since the Sumerians invented maths. A creation that would change the world. They invented an entirely new number. And it's in here, inside this tiny 1100-year-old temple in Gwalior, northern India, is this new number. And after a 4,000-mile journey, I'm finally going to get to see it. Nick, it's locked. So we wait, and while we wait, I start to wonder, how was it that this new number wasn't invented sooner? It's such a simple little number that takes only a moment to say and even less to write. Ah, here he is. But once invented, it transformed the life of one in a way that would eventually change the entire world. Well, here we are. The first undisputed example of India's greatest invention. The new number. The holy grail of numbers. 0. For the first time in human history, someone had made nothing a number. The inscription says that a garden was planted to produce flowers for the temple. And to ensure that they had enough, that garden had to be 187 by 270 hastas, about 20 acres. Well, while the Romans were using numbers to record their conquests and count dead bodies, these people were using them to make sure they had adequate supplies for their flower arrangements. Well, you might say, what's all the fuss about? I mean, what's so wonderful about inventing a symbol that means nothing? I mean, if somebody asks me how much I've got in my hand, I can just say, well, I haven't got anything in my hand. I don't need a 0 to do that. Well, a 0 on its own would be nothing, well, obviously. But when you teamed 0 up with 1, magic started to happen. And when they were joined by the rest of the troop, the results were spectacular. With just 10 digits, the Indians could make numbers infinitely large, as well as infinitely small. Now, the Romans couldn't do that. One had found his perfect mate in Zero, and it was a partnership that was going to change the world. Together with the rest of the team, they enabled Indian science to storm ahead. Indian astronomers, for example, were centuries ahead of the Christian worlds. Indian scientists worked out that the Earth spins on its axis and that it moves round the sun, something that over in Europe Copernicus wouldn't figure out until 1,000 years later. Indian scientists also calculated the diameter of the globe, and they were less than 1% off what it actually is. All this was possible because of 1, 0, and the rest of the troupe of performing numbers. They were a sensation, and their fame soon began to spread across the globe. A conflict with the numbers of Rome was bound to happen sooner or later. But for now, 1 and 0 and their friends made their way across the deserts of Arabia to take on one of the most sophisticated societies of the age, in what is now Iraq. When Islam was little more than 100 years old, Baghdad was ruled by the great Caliph Al-Mansur. Now, the Caliph wished his people to live according to the Quran, so he set up courts and judges to apply the law of the Prophet.
ناديني على الوزير. تفضل.
Now, the law of the Prophet is full of instructions that require serious mathematical calculations if they are to be carried out exactly. For example, unlike Christianity, the Quran insists that women share in any inheritance. The book says there is a share for men and a share for women, each share depending on the number of other relatives and their relation to the deceased. Working all that out required fractions and ratios, but these were people who counted on their fingers. It's not like they weren't up to complex arithmetic, it was just their number system was holding them back. But one day, there arrived in the court an ambassador from India. He had to present the great Caliph with a gift of some sort. But the Caliph was a man of infinite riches. It was hard to know what to give. I mean, an I Love India t-shirt was hardly going to do the job. The ambassador, however, had thought long and hard about this, and had decided to present the Caliph with the greatest gift he could think of. The gift of numbers. Actually, we don't know for certain exactly how Indian numerals came to be adopted in the Islamic world, but the ambassador story is my favourite. What we do know is that Muslim scholars were bowled over by 1, 0 and the rest of the troop. And the most famous of these scholars was a man by the name of Al-Khwarizmi.
Al-Khwarizmi.
Al-Khwarizmi. Khwarizmi?
Al-Khwarizmi.
Al-Khwarizmi.
That's right.
Al-Khwarizmi and his colleagues taught the performing numerals a whole host of brand new tricks. Quadratic equations, algebra, reversed, logarithmic, cubic cake, handstands. Well, okay, I made that last one up. But these new numerical feats enabled science, mathematics and astronomy to reach new heights in the Middle East, and the Indian troupe became a smash hit throughout the Islamic world. But on the other side of the Mediterranean, Christian Europe was still in the static grip of the old army of Roman numerals. And being Romans, they weren't going to give way to the feisty newcomers that easily. A showdown between the two systems was inevitable, and when it came, it would shape the destiny of the Western world. The beginning of the end for the Roman numerals started on the shores of North Africa. Muslim traders had been quick to adopt Juan Zero and Co. for their business dealings. By the end of the 12th century, the Indian numerals were in common use. And it was in the bustling port of Béjaïa that the young son of an Italian diplomat based in Algeria first witnessed their amazing act.
When I had been introduced to the art of the Indians' 9 symbols, knowledge of the art very soon pleased me more than anything else, and I came to understand it.
That young man was known as Fibonacci, and he was so knocked out by the Indian numerals that when he grew up, he decided to take them home with him. In 1202, Fibonacci wrote a book all about calculation, called, well, the Book of Calculation. He's now regarded as one of the greatest mathematicians of all time, and his book was pretty much a showcase for Indian numbers. But Fibonacci wasn't just an ivory tower theorist. Part of his Book of Calculations was aimed specifically at merchants, showing them how useful Indian numerals could be for, say, calculating their profits. Not exactly a page-turner, you might think, but this was a time when capitalism was beginning to come out into the open in Europe. Fibonacci's book was a must-read. Unfortunately, ordinary people felt comfortable with the old numbers. After all, they'd lived with them part of 1,000 years. The old Roman numerals weren't going to make it easy for the Indian newcomers. And it wasn't just a question of tradition. Your average punter had some pretty good reasons to prefer the old system. For example, many medieval Italian cities had their own currency. So every time I found myself at a new town or a new set with extras in costumes, as the case may be, I have to go to the money changer's bench, or banker, as it's called. A banker was a counting table, basically an abacus with counters instead of beads. The men who operated them, the bankers, had to swear an oath not to cheat their customers. Mind you, if the magistrates find he is cheating me, they'll come and break his bench. His banker will be rupta, which is the word for broken. And he'll be declared bankerupta, which is where we get the word bankrupt from. Hi. Now, these things, how much can I get for those in whatever place this is? He's counting it now. It's reassuring to see he's using numerals I'm familiar with, which are Roman numerals, of course. And he's using this abacus, so at least I can see what he's doing. And I get that much. Oh, right, fine. Well, thanks a lot. Nice doing business with you. But what if I was to go over to one of the smart chaps using the newfangled Indian numerals? Hi. Now, how much would you give me for that? Now, you see, this is the problem. You see, as a medieval punter, I've got no idea what he's writing. I mean, no wonder people were suspicious. I mean, if my bank started keeping my accounts in Chinese, I'd be suspicious. Oh, thanks. I've got no idea how you arrived at that. But thanks anyway. This distrust went right to the top. In 1299, the city of Florence actually banned merchants from using the new numbers in accounts. They had to use Roman numerals. But no number was treated with more suspicion than one's partner, 0. One writer called 0 a sign which creates confusion and difficulties. Zero was called cipher, and it was regarded with such suspicion that that word became our word for secret code, a cipher. But the days of the old system were numbered, and I suppose you could blame good old human greed. The traditionalists who clung to the abacus and Roman numerals had never had to calculate interests on loans because the Catholic Church said charging interests on loans was a sin. It was called usury. But come the Reformation, the Protestant churches were more business-friendly, and the long-held Christian objections to capitalism seemed to, well, disappear. So, in this new money-lending, interest-charging environment, which would prove the more useful, Indian numbers or the abacus? Well, let's find out. On my right, one first-class mathematician. On my left, one first-class abacist. So, supposing I lend someone £10 at 0.5% interest a month, how much do they owe me at the end of the year? Okay? Ready? Steady? Go!
Kimmy's been an abacist since she was just 15 and is using a modern Soroban model. But just as they did in the 16th century, she's rounding her numbers to the nearest penny as she goes. Let's hope she can round herself up into first place. Marcus is using a pen and paper, so he's working to an eye-popping 12 decimal places. He lives in North London with his lovely wife Shani and 3 charming children. He's not big, but he is clever.
The Kimmy has got an answer. Kimmy,
Yes.
what's your answer?
£10.60.
£10.60.
Yes.
So compound interest after a year would be £10.60, and the abacus seems to have got there before the mathematician.
Well, I don't want to put a damper on things, but I think that answer is actually wrong. I've got an answer of £10 and 61.6777664035 pence to be precise. I've actually picked up the subtlety of compound interest, which is it's a little bit each month, but it adds up. So I've got this extra 1.67p.
For the medieval businessman, it would mean the difference between making a living and not. Maybe that's why the abacus user looks so miserable. As capitalism gained respectability, calculating interest and compound interest became de rigueur for any self-respecting businessman. And for doing that, even with an abacus, the old Roman system was simply no match for the Indian numerals. So, centuries after Fibonacci had brought them to Europe, the Indian numbers finally outmaneuvered the lumbering old Romans. They were quick and versatile, and with 1 and 0 in the lead, just better at teamwork. When the end came, it was a pushover. The old Roman numerals were at last bankarupta. But 1 and 0 had even bigger plans for the future, and they didn't include the other numerals. In the meantime, the full troop of Indian numbers took over the Western world. With them, European navigators found it easier to calculate their latitude, and so dared to cross the great ocean out of sight of land. That's how they stumbled on America. And the new numbers became the vocabulary of modern banking as we know it.
Hello.
But there was still plenty of room for that old problem, human error. Columbus thought he'd got to Japan, when in fact he'd got to the West Indies, half the world away. He'd made a mistake. Humans do, which was something one man was determined to stop. It all happened round about 16... Well, there you are, you've got it again. Gottfried Wilhelm Leibniz was one of the greatest mathematicians of all time. He set out to rid mankind of the curse of human error. In trying to do this, Leibniz invented something that still affects us every day of our lives. What's more, it's an invention that was to give our old friend Juan the chance to rule the world. Leibniz was convinced that he could eradicate error by inventing a mechanical calculating machine. And in fact, he built one, using all the numerals from 0 to 9. But then he had a better idea, and it was one that was inspired by his philosophy.
It is true that as the empty voids and dismal wilderness belong to 0, so the Spirit of God and His light belong to the all-powerful One.
In other words, to paraphrase Leibniz very, very, very loosely, the universe is a bit like a Swiss cheese, which some of us have suspected for years. The holes are just as important as the cheese itself. So to construct the world, you need both something, good old number 1, and also lots of nothing, which is where 0 comes in. Leibniz was convinced that 1 and 0 were the only numbers that anyone really needed. With these two numbers, he claimed, he could achieve every mathematical dream, and, what's more, eliminate human error. So he got rid of the other numbers and developed a system using just 1s and 0s. It's called the binary system. And yet, wait a minute, how could you possibly express all numbers just with a 1 and a 0? I think it's time I spoke to someone who knows what he's talking about. Marcus! I need to understand the binary system.
Binary. Okay, let me give you a number in binary.
Okay.
Here is the number 9 written in binary.
So this is just using 1s and 0s.
1s and 0s.
Any number.
It's just 0s and 1s. So that's 9 in binary.
Well, it looks like 1001 to me.
That's because you're obsessed with your 10 fingers and you like to keep track of things in tens. Well, this one keeps track of how many 1s, the second column of how many 10s there are, next how many 100s, and one lot of 1000s. But in binary, things work rather differently. In binary, what the columns keep track of is how many 1s, how many 2s, how many 4s, and how many 8s there are. Here we have an egg. We're only allowed to represent these numbers using 0s and 1s. Yeah. Okay, so we're only allowed to either to put an egg in or not have an egg.
An egg in is 1.
An egg represents 1. So let me show you what 9 is in binary. One lot of 8, so I have an egg in the 4th column.
It's a 1.
Yeah, that's one lot of 8 in the 4th column. And 9 is 8 plus 1, so I need a 1 in the 1s column. So in binary, the number 9 is one lot of 8, no 4s, no 2s, and 1 1.
Amazing. But what about the other numbers? Well, after just 3 short hours of tuition, I began to see that it was possible, after all, to make every number using just 1s and not 1s. What's more, I became convinced that you don't need to do it with eggs. It's a sort of mechanical system.
It's very mechanical to add the 1s and 0s, and that's why it's perfect for a machine. And a machine doesn't really care too much about how big the numbers get. It can keep track of very long numbers, whilst we're not very good at doing that. What it's interested in is a very efficient way of adding numbers. That's why machines love to put numbers into binary.
And Leibniz designed exactly such a binary machine. Only his was using metal balls dropping into slots instead of eggs and egg cups. From now on, mistakes would be a thing of the past. The digital age, it seemed, was ready to take over the world. Unfortunately, he never built it. 1 and 0 would have to wait another 265 years before they could step into the limelight. Meet Colossus, the world's first working binary computer. It's Leibniz's dream made real. But instead of dropping metal balls into slots, Colossus is electronic. In here, 1 and 0, something and nothing, have finally come into their element as electrical currents, on and off. Colossus was created during the Second World War and installed here in Britain's code-breaking centre at Bletchley Park. It has 1,200 valves, miles of wires, hundreds of mechanical components. But just like all computers today, the beating heart of this machine is 1 and 0. In their electronic binary form, 1 and 0 performed millions of rapid calculations, enough to crack the enemy's codes before the Germans had even sharpened their pencils. Thanks to Colossus, the Allies knew what the German messages said even before Hitler did. And it may be that this extraordinary contraption helped shorten the war by as much as 2 years. The technology that started here in Bletchley has changed our world forever. You remember all those reasons for using and understanding numbers, doing astronomical calculations, working out measurements, and juggling with the divisions of property? Computers can do it. Working out percentages, currency exchange rates, and compound interest. All that calculation that preoccupied and sometimes perplexed the great minds of antiquity. Just leave it to the computers, and we can all simply be happy ignoramuses, not even knowing whether the answer's right or wrong. And that's got to be a good thing, isn't it?
Terry? Where are you going, Terry? I say, you're not leaving me, are you, Terry? Terry! Terry!
In the computer age, our whole world runs on a stream of ones and not ones. From our bank statements and medical records to the barcode every time I buy a tin of cat food. And the rest of the numbers can be consigned to the dustbin of history. 1 and 0 are all we need. The old performing duo have come out on top. Let's just hope we can control the little blighters.
Well, I thought I was rather good, didn't you?
I thought you were marvellous.
Sublime.
I would,
They
then.
kept my
And the
astronomy.
I much preferred working with Michael Palin.